Yes, students. Last class we discussed the data types. Now we would like to discuss data type ranges. So every data type is having its own range actually. Suppose if you consider here integer, this integer is having 4 bytes. Integer is having 4 bytes memory here, and it is having signed. Signed means it will take the negative values and positive values. So the range is almost is 2 billion 147 lakhs 147 millions 4 lakhs 83,648 to 2 billions 147 millions 4 lakhs 83,647. So if you give the values beyond this range, okay, it will not consider. So the values will be repeated in this ranges only. Simple example, suppose if I am considering this range minus 128 to 127. So here what will happen? Here minus 127, fixed value minus 126, so like that 0, 1, 2, and so on up to 126 and 127. Suppose if I assign 128, it will not take. What will happen? If I assign 128, again it will come to, it won't take 128. It will come to here directly. It will come to here. So if I store 128, so it will not take. It will come to 127. So the values will be within particular this range only. So even if it is unsigned int, unsigned int means we are having only positive values. Whenever you want only positive values, you can consider it is unsigned int. Unsigned int means it will not consider negative values, only positive values. Almost 4 billion 127 194 million 9 lakhs 67,295. Suppose if I give 296, it will not consider. It will come to 0 again. This is happening. So only the values will be within this range only. It will consider. Sir, if I want more range, what to do? So if I want more range here, we can go for long. Long is there. Okay? Long int. Long int. It is also same range, but if you want more values, here you can see. This is long you can consider. Okay? So based on this, it is going to consider. So even if you consider here this 808 after this 807, if you give 808, it won't consider. It will come to the same starting value. Even in this example also, if you give 65,535, it won't consider. Again, it will come to 0. So if you give beyond the range, again it will be in this range only. Okay, this is happening actually. So we will see one small example. We will take the same value and let us see what happens. Here the range is see, unsigned int I am taking, this value I am taking. So you store here unsigned from n value. So generally it won't take commas. So I'm taking this value and just I'm printing. If I'm not doing anything, just printing. Okay. So see out. Actually, we need to use using namespaces. Because if you don't use this using namespace std, generally we have to use the std and different colon. So every time you have to give like this. So to avoid this every time, generally we are giving using namespace std. You see how the exact value. Suppose I am taking 6 here extra and this. So it won't print. It will come to the starting point. The starting point is 0. Okay. So even if I give 97 also, it won't consider. Okay. It will give result 1. Yes. This is happening in the data type. Even in the double case also. Suppose if I consider double. Double n equal to some big value if I consider. What will happen? Let us. So generally in exponential, we are getting, if it is a long value, big value, we are getting exponential. This is like 10 power 9, 10 power 9 plus 9. Suppose if I want all digits, what to do, sir? If I want all digits, you can do one thing. It needs one library. I will manage, and you have to use like this. So what happens here? So now you see it gives complete all digits. It is giving all digits. So this is suppressing the exponential. So it is suppressing the exponential means all digits, whatever the digits I want, all digits I can take. Even I can take long also. Big values, double values also I can consider. So it will be printed. Even big values. When I'm adding some digits here. So all digits will be printed. All digits. If you want to print all digits, you have to include this manip. You go and fix it. So how you want to show the result, as per that you can see. If you want all digits, you can go for this I1 manip. Otherwise, if you want exponential, by default it will give exponential. So based on the range, it will take range based on the data type range. So here everything is available for integer. It is taking 4 bytes. Signed, and if you want to avoid signed, you can go for unsigned. Similarly, all details available here for characters, double, float, long. So for each and everything, how many bytes it is taking? Long means 8 bytes it is taking. That is why more range. Range is more. So float range almost it is 7 digits here. Exponential plus or minus 38. We want still more. This is exponential 38. Almost it is giving 15 digits. Double. It is giving 7 digits. It's all how you are taking the values and how you are printing matters. Next, we will go to the next topic. Yeah, next we will go to the operators. We are having different types of operators. So we will discuss one by one. First, arithmetic operators. So arithmetic operators you know already. Just addition, subtraction, multiplication, division, and percentage. So what is percentage? What is division? We will see here. Suppose here I am taking one simple you want, you can save here and you can go to the next project. And you have to select the projects. So just I'm taking two values, enter a equal to 10, b equal to 3. C. Just I would like to store C equal to a by b. A by b. So what is the result? So we are not getting any result. Why? Because actually the here what is happening? So A is the memory location. This is the memory location. B is another memory location. Here we are storing 10. Here we are storing C is another memory location. 10 plus 3, 13 stored. Okay, 13 stored, but we are not getting any output here. Why? Because we are not giving any instruction. Okay, we have to give the instruction, then only it will act. So until and unless you are saying print, it won't print. So you have to say that print. It means see out. So let us see. Now I'm giving the instruction. See out. For every statement, generally we are using the terminator, semicolon is compulsory. Semicolon, terminator is compulsory. See out means this using namespace HTTP is compulsory. Because this is, but actually, what is the answer? 3.333 actually, but we are getting only 3. So you see, here we are dividing with 3, then we are dividing, and 3 3 is the 9. So remainder is 1, and quotient is. But whenever you are using this slash, this answer will be remainder only. Sorry, this quotient only. Suppose whenever you want remainder, you have to use a percentage modulus. So then this will be given. If you want remainder, you have to use a percentage. If you want quotient, you have to use slash. Sir, if I want 3.333 like that, fraction also I want to print. For that purpose, what to do? For that purpose, generally we are using typecasting. So here you can take it as D value, and I am taking E, some more value E. Here you have to use the typecasting. This float, you have to make it as a float. Actually, A is the integer. A is integer actually. But we are converting that into float and slash B. So that in this case, we'll get the output. The output will be 3.3 actions you are getting. So whenever you want the fraction values, should make numerator or otherwise the denominator some float value. There must be some float value. Okay. So we will see the output. Here I am taking D equal to a percentage. Similarly, E equal to float. Typecasting. This is called typecasting. Now let us print one by one. So just I am using endl. Endl means it will give in the output. We are getting the output in the next line. So now let us see the output. We have to declare. Declaration is compulsory. You see, it is showing that it was not declared. Every time you have to declare. Okay? So here, before using that variable, you have to declare it as an integer. And this is also integer. You can declare at the beginning, otherwise you can declare anywhere also. Before using that variable, you have to declare. Even in the middle also you can declare, or even in the beginning here also you can declare DE. Otherwise here also. Sorry, float A. A you have to mention. Now you see. So first one is giving C. C is, what is C value? A slash B. A values, first one is 3 actually. First one is C value and the quotient. Okay. Next D value remainder. Yes. Remainder 1. Right. Next again we are getting 3 only. Why? Because we declared E as an integer. That is the problem. So integer means only integer problem. Integer will be printed. You should declare it as a double. Otherwise float, whatever it is. Double or float. Now let us see. Yes, now we are getting. E is the next one. C. Here D we are. Next D. Here remainder percentage. A percentage. Next here we are getting the 3.33. So how you want output, as per that you have to follow. As per this you have to follow. So remaining addition, subtraction, multiplication, you know already. So this is very important. The slash and percentage. Next operators. Next assignment operators. Assignment operators are here just like generally we are assigning a particular value. Arithmetic operations over addition, subtraction, multiplication, division, and modulo. Assignment operator means generally we are taking A equal to 5. What is the meaning of A equal to 5? There is a memory location A. The name of the memory location is A, and 5 is stored here. That is the meaning. Sometimes we are writing A is equal to A plus 1 sometimes. So what happens now? So in this instruction, after completion of this instruction, next instruction we are taking A equal to A plus 1. That means A becomes 6. This 5 will be deleted and 6 will be 5 replaced with 6. So instead of this statement, okay, I can go for another statement, that is A plus A, A plus, so also you can take. Okay, this is another statement, increment actually, increment or decrement. Otherwise, suppose these two are coming under the same category. Suppose if I want to add A, I have taken 6 initially. Now A is equal to A plus 5, I would like to add. Now what happens? 6 plus 5 and 6 replaced with 11. So instead of this statement, can go like this: A plus equal to 5. Both are same. Assignment operators. Even if you want to give like this, A equal to A into 10. You can give like this, A star is equal to 10. Okay, you need not give A 2 times, but the meaning is same. The meaning is same. Both the meanings. Next, similarly, A equal to A by 10. So A by equal to 10. Both are same. Both are giving same result. So similarly, percentage and all. They are assigning. This is assignment operator. Assignment. Next, relational operator. Relational operator means here you know already less than symbol, less than or equal to. So in mathematics we can write less than or equal to, but here it is not valid. Okay, in computer programming generally we are using like this. Here greater than or equal. So similarly equal to means double equal to we have to use. Remember, we should not use single equal to. Single equal to means it is assignment. Single equal to for assigning. Okay? Assigning values. Double equal to for comparison purpose. So whenever you want to compare, generally we are using relational operation. Comparison purpose. Okay. This is for comparison. Comparison. This is for assigning, remember. So double equal to we have to use. Single equal to means it will assign the value. Single equal to means suppose if you are writing a equal to 5, a equal to b, what happens? Suppose a value is 10 is there, b value is 12 is there. What happens? This a value will be stored in a. That means 10 will be replaced with the 12. This will happen. But if you say a double equal to b, it's different. Double equal to b means previously a was 10, no? Previously a was 10 and b was 12. So we are comparing. Are they same? Like that we are comparing. This is the comparison. Both are having different meaning. Assigning single equal. Comparison double equal. Suppose not equal. Not equal means not and equal. Not and equal. Say not equal. Not equal. This is equal. Next, these are logical operations. Logical operations. So logical operations means suppose if you want to use both condition, both are same and condition. Whenever you want to use and in programming, we should not write a and d. We have to give the symbol. Whenever you want to write or in programming, if you give or, it won't understand. You have to give this. Whenever you want to state not in programming, okay, you have to use the symbols. These symbols you have to use. These are logical operators. So two conditions checking. Okay, in that particular cases, and this condition satisfied and that condition satisfied. Suppose a greater than b and means we are using and a greater than c, and simple. Suppose a greater than b or if I want to use or, okay, like this we have to write. This is important. Increment, decrement. Just now I told you. Suppose if you want to write like this, a equal to a plus 1, simply we can write on a plus plus. That's same. Similarly, if you want to write a equal to a minus 1, simply you write on minus plus. For having same. Bitwise related to some 1-0 operators, 1-0 values that we will fill in. Next, ternary operator. Bitwise, the name it is indicating bitwise means it is this concept will be discussed in the DLD subject actually. So zeros ones will be there. Operations on zeros and ones. Next, the conditional ternary operator. This is important. Ternary operator, what is happening, we will see. Here, ternary operator means question mark and symbol. Suppose I am giving like this, C equal to a greater than b question mark a colon So what happens? Suppose if this condition is true, okay, if this condition is true, if this condition is true, suppose, then this A will be stored here. A will be stored in. Suppose if it is false, okay, suppose if it is false, that condition is false. Suppose this condition is false, this will be stored. A will be stored. Ternary operator based on the condition. If this condition is true, A will be stored into C. And if this condition is false, A will be stored into C. So this we will see in the now A and B have already stored here. This time using the ternary operator A greater than B. Good. Question mark. Colon B. So now I am printing 0. Not well. Whatever you are writing within double inverted comma, that will be printed in the output. Okay? Whatever you want to print out, okay, that should be within double quote. This will be printed, and whenever you want to print value, you have to give this. So in this case, what is happening? A is greater than 10 greater than 3. 10 greater than 3 means 10 will be stored into C. 10 will be stored into C. So 10. 10 is the logic. 10 will be stored into. Suppose if I am giving here 30, what happens? 10 greater than B. Condition false. 10 greater than 30. Condition false. So B will be stored. B will be stored into C. Now let us see. The large value is 30. So these are operators. Different type of operators. The operators you need to remember. Arithmetic operators, assignment operators, relational operator, logical, increment, decrement, bitwise, conditional. So these are very important. And with the operators, we will see that. Remaining things we will see in the next.